Draw the Lewis structures for CO3, CO2, and CO, including resonance structures when appropriate. So to start off, let's put C in the middle, and this is CO3. So we know I'll have to attach to 3 oxygen molecules. But the thing is that there's 1 bond left over because carbon needs 4 bonds to be completely ionized. So it needs to have 1 more bond with one of these. So it can be any of them. It can be this one, it could be this one, it could be this one. Any of them work. And also we know that it has 2-, which means that the ones that aren't having 2 bonds will have extra electron. So oxygen with 1 bond would usually only have this many electrons, but with an extra one, it'll be completely ionized. So that's the structure for that one. Now, if you go to CO2, this one's pretty simple because oxygen needs 2 bonds and carbon needs 4. And because there are 2 oxygens and 1 carbon, it works out perfectly. So carbon bonds twice with both oxygens. And this is the Lewis structure. Very simple. So now CO. So we have carbon and we have oxygen. Now they might have a 2 bond, but I think a triple bond would be more appropriate here. Because with 10 total electrons, because carbon has 4 and oxygen has 6, if they share 6 of them right here and then have 2 for themselves each, that would equal 10. So what we do is carbon would have a negative charge and oxygen would have a positive charge, but they would cancel out. So this would be the Lewis structure for carbon monoxide. Moving on to question 2. Which of these 3 species has the shortest CO bond length? Explain your reasoning. So I think it's just carbon monoxide because, as we know, when you have a bond, the stronger the bond is directly corresponds to if it's a single bond, double bond, triple bond, quadruple bond. Because the 2 atoms are closer together, so a triple bond would be the strongest here. And since we only have one with a triple bond, we can safely say that carbon monoxide has the shortest bond length here. Provide the molecular geometry of each species. So to do this one, we go on to Brester's handy VSEPR chart, and we just go down the thing. So for CO3, we can see that it has 3 bonds. So we go down here, and because there are no lone pairs, we can see that it would be trigonal planar. So CO3 would be a trigonal planar. So CO2 now, this one has 2 bonds, and there are 0 lone pairs, so it would be linear. And then finally, we have CO. CO only has one bond, which just leaves us with a linear shape. So that one would be linear. And there you go.